So now we are showing you the data sheet, the typical data sheet of an NMC cell and an LFP cell. So here you can see a typical data sheet of an NMC cell. So every one of you can see here, this is a like from a particular manufacturer. We are not naming the manufacturer. It can vary. And every manufacturer, when he is selling the cells, he will be giving you a data sheet, so that it's kind of a certificate of a cell. Okay, so you can like cross check like what would be the features of your cell, the cells that you are purchasing. So normally what it would carry, first of all, what we have said is the geometry. What are the cell geometry? So typically if you talk about NMC cells, they are available only in cylindrical geometry. Here you can see like the first 1 2 3 4 5 6 type of cells we has been data sheet of 6 type of NMC cells have been given by the manufacturer. So here you see 18650, second is again 18650, and so on, and only the last cell that we are discussing is this 21700 geometry. So we discussed in the last lecture also, the first two digits signifies the dia of the cell, and the next two tell us about the length of the cell. So this cell, if I talk about the first cell, then 18 mm is the dia of the cell and 65 mm is the length of the cell. So for the first all 5 cells, the geometry is same. Only in the last case, it is a bit bigger cell, where the dia is 21 mm and the length is 70 mm is the length of the cylindrical cell. Okay, so typical capacity you could see, the normally given it either milliampere hour or in ampere hour it is given. Okay, and that is at a particular C rating, that is the typical the capacity that is given. So if you are discharging it at a particular C rating, then only you will get that amount of capacity. So under certain conditions, the battery capacity is given. So here in the case, you could see that it is 2 Ah for the first, 2.5 Ah. Then again in the third case, there are two types of cells, so 2.2 and 2.55, 2.6, 2. And it goes as high as 4.1, 4.5, 4.85 Ah also it goes up to, because the cells that we are considering in the last column are a bit bigger cells. Nominal voltage, if you see in NMC cells, the nominal voltage is 3.6 flat. Normally the nominal voltage is standard or the same irrespective of the age the battery is holding. Okay, so and weight, if you talk about, all are 48 to 49 gram of weight. Only in the last case the cell is bigger, so the weight is 70 gram. And same, the internal resistances are also different for the different type of the cells. Discharge rating, the normal standard discharge rating, they have rated it at 0.2 C. So if we are discharging the cells at 0.2 C, so if you talk about the C rating, so it is the ratio, or it is a multiplication factor to the capacity of the battery at which safely we can discharge or charge the battery. So every cell will have two discharge, two C ratings. One would be for charging and one would be for discharging. Okay, so in this case, if we talk about it, if it is 0.2 C, then it would be, the cell would be can be safely be discharging at 0.4 C, 0.4 ampere continuously current can flow without damaging the cell. Maximum 15 C, 10 C, different maximum rating is also good. That is only for particular instances, conditional base, say for 4 or 5 seconds only that will prevail. So for 4 or 5 seconds, we can discharge the cell as high as 15 C. So 15 C, if you can, if you imagine, it would be like at 30 ampere of current can flow through this. That would be only conditional base, and here they have not mentioned the time slot. Otherwise, it would last only, it can only be accommodated only for few seconds. And if you talk about discharge rating, we have told about, same is the case with the like for charging also, we have a particular C rating. Okay, so you can discharge the cell at a particular C rating, and you can also charge the cell at a particular C rating. So either you are withdrawing current from the cell or the battery, or you are pushing in current or current into the cell or the battery. That can be done at certain standard rates. It could be done. They are typically called the C rating of the battery or the cell. Temperature, you can see the during charging and during discharging, the temperature ranges that they could withstand. those are also mentioned over here. And life cycle. So life cycles, as we have discussed, that the life of a normal lithium ion batteries or any battery, if you talk about, they are given in form of cycles. So one charging, one discharging would be called as one cycle. Okay. And normally the battery, we would say the battery life, we would normally define the battery life as when it only charges up to the 80% of its capacity, then we would call it has lost its life, and now it is time to replace the battery or to go for a new battery. Okay, so 80%, if it has gone below the below its life, then we would call it as a then it has lost its life. So that would happen normally when certain number of cycles have passed by, or we have used the battery for certain number of cycles. So you can typically, you can see that in first case it's 300 cycles, in next case is 300 cycles, and it could be like we could go as if we go, and in 300 cycle its capacity will go as low as 70% of its full battery life, battery level. If we talk about, then it would be 70% of it would be achieved in 300 cycles. In this 60, it would go up to 60% of like full charge voltage only it would be able to retain, or it would be able to charge. Now in third case, if it's so if we see it's 1000 cycles, then 500 cycles, 1000 cycles. So typically if you talk about NMC cells, they are between 1000 to 1200 cycles only. So this is like we have studied about the NMC NMC battery. We have discussed about the NMC battery. Now we see like LFP cells. If we see, so LFP cell, if we typically see, you can see the geometry of the LFP cells. So they are much bigger when you compare it with the normal NMC cells. If you talk about, these are all cylindrical cells that we are discussing right now. So they now if you talk about the prismatic cells, then their geometry will will be different. They would be in the form of the cuboid structure. They would be in the form of the cuboid structure, or the canisters we can call it. So they would be holding more like or more power, more energy they would be holding in a single cell. So here you could see we are right now discussing only the LFP cylindrical cells. So here you could see that the geometry, if you talk about, so it starts with 26650, 26700, 26700, 32140. So here all what you can see is like these are like bigger cells than the normal NMC cell. So 26650, if you talk about, it has a dia of 26 mm and a length of 65 mm. And in the last cell, if you talk about, the dia increases to 32 mm and the length is 140 mm is the length of the cell. So here typically same thing. If you talk about the capacity of the cell, the capacity, holding capacity, if you talk about LFP cell for the same geometry, the holding capacity would be a bit lower than the NMC cell. Okay, so we will be able to utilize a bit lesser energy. We would be able to withdraw lesser energy from LFP cell in comparison to NMC cell, because their operating range that we are discussing around the nominal voltage is a bit shorter. Okay, so that is more for the safety concerns and more for the safe levels. They have kept the energy retaining capacity and what we can withdraw from the cell to a bit lower than normal NMC cell. Weight, if you talk about, they start from 88 gram and can go as high as 300 grams if you talk about 32140 FS cells. Internal resistance we have discussed, they are different for different cells. Definitely for the same kind of cell coming from a different manufacturer, the internal resistance might differ. Discharge rating 1C, then if they are bigger cell, then they have defined safe levels at 0.5 C. Discharge maximum 10C, 20C. And for bigger cell, then again maximum also they have reduced it to 2C. Okay, and as we discussed that maximum is only for a very short span of time. End voltage, end voltage is the voltage the lowest voltage till which the battery would be operational, below which the BMS will not allow the battery to discharge further, and it would be the battery would be cut off. So this would be the end voltage. And like discharge, again, standard, if charging we talk about, then 1C, maximum it could be 3C if we talk about the first kind of the cell. Then end voltage 3.6, this is the highest level of voltage. So nominal is 3.2. We already discussed that every battery, every cell is normally rated, the rated voltage is the nominal voltage. So it would be the higher side end voltage, and the lower side end voltage would be like 10 to 12% on higher side and 10 to 12% on lower side. So that would be called as the complete operating range of a battery or a cell. So end voltage is 3.6. So maximum it could charge up to 3.65 voltage. Nominal is 3.2 voltage, and the lowest it could discharge to up to 2 voltage. It could discharge to a single cell if we talk about. Now, temperature ranges, again, charging and discharging, they've given the slabs till which they can operate. So this is like, it's not ambient temperature. In fact, it is a temperature that could develop within the, sorry, it's the ambient temperature or the ambient temperature conditions in which it could operate. Okay, so they have given a full temperature range where it could have operate. So you could see that even at -20 it could operate. So even in the places where you witness snowfalls or which are very cold, there also they would function. And life cycle, if you talk about, see, life cycle has increased from NMC, which we were seeing from 300 to maximum 1000 or 1200 cycles. Now it has increased to 3000 cycles in case of LFP cells. So LFP cells are they could be utilized for more number of cycles. Definitely with a single full charging, we can utilize lesser energy. So, but in the long run, they will give us their life is longer than the normal NMC cell, if you talk about. So, in addition to what we have discussed, the data sheets that we have discussed, that was to give you an idea about about the selection of the cells when you are going to assemble a battery. Then what would be the parameters that you should know about the cell when you are assembling a battery, because we already discussed that we are limited with the smallest unit in our battery, that are the cells. So in any way, when we are going to assemble the battery, we have cells which are in standard sizes only. So we have our dimensions, everything will depend upon them. So we should be at least aware of the quality of the cells and the data sheet of the cell. So we know that like whatever we are when we are assembling a battery, what would be its output and how the battery would be. So quality control won't be an issue if we are aware of the cell data sheet. Now, these would be the major contents that we will be covering going ahead. Typical battery problems, then BMS we will be discussing in brief, then battery pack, maintenance of batteries, and battery safety and disposal. So typical lithium-ion battery problems are the problems that they face. So they overheat and explode if charged too fast. Short lifetime, they die after less than 1000 charge or discharge cycles. Flammable, they use chemicals that are flammable, toxic, underperformance in extreme temperature, expensive casing, and expensive to transport. Okay, so these are the typical disadvantages that are associated with the lithium-ion batteries, which some are again there for normal lead acid batteries also, but these are some hazardous flammable, toxic, these that we have discussed, they are like typically with lithium-ion batteries only. So they overheat and explode if charged too fast. So if say we have initially in the first slide when we were discussing on the data sheet of a cell, we have discussed that there are C rating for the charging and for the discharging. So at times what happens is just to attract the customer, the OEM could say that my battery charges or the battery of my vehicle charges in an hour or half an hour and all those things. So charging fast means pushing in more current at a higher amperage if you are pushing in current. So if that at any point of time that is beyond the safe levels or the safe charging C rating of a cell, if that is there, then this could create problem, and there could be like fires, because the overheating could there could be overheating in the cell, and then that could affect other cells, and there could be, because it holds lithium ion, which is highly flammable element. Okay, so that could happen due to fast charge and short lifetime. They die after less than 1000 charge and discharge cycle. So this is typically case with the NMC cells. Now definitely, now technologically they are advancing, and new technologies are coming. As we discussed in LFP cells, the cycles they are trying, the new batteries that are coming for more cycles. So in typically in four-wheelers, if you talk about, there are like the batteries could be utilized as for as high as 5 years also they could utilize. 5 years or 7 years, and in fact their second use is also like they could be after the EV in 7 years, instead of disposing it, the battery can be given a new life also. It could be given where it can be utilized for or normally energy storage. It could be utilized. Flammable we have discussed. They use chemicals that are flammable. So lithium is there, and other elements are there which are flammable. So if at any point of time the heat has there is generation of heat, then that could create problem in the battery. So toxic. So when the battery catches fire, or when what happens is like the chemical or the compounds that are used in the cells, they release harmful gases. Expensive casing. So casing, care is taken, a lot of care is taken, so that the casing is made a bit robust, so that even so that it could first of all it could take care of the shocks, and at the same time like the temperature variation could be taken care of, and even if there are and special care is taken so that it is made waterproof and dust proof. Okay, so that at any case like if vehicle is running in during wet weather, so that the water seepage or there are very less chances of water seepage, so to avoid that, so that the battery damaging due to water can be avoided. So this taking all these factors in, if you take all these factors, then the casing becomes a bit expensive. So we have to take special care when we are designing the casing of the battery also. Expensive to transport. So what happens normally when you are transporting this lead acid batteries? So you must have seen that they are like normally put into corrugated boxes. Then there could be a small pad could be there below them that could take care of the shock, and they could be stacked one over the other. Okay, stacking is a major issue in case of lithium ion battery. So it is very strictly restricted that there should not be stacking. So when we are even importing, okay, when we are importing the batteries, a lot of care has to be taken when we are stacking in the containers, when we are stacking these batteries. So we have to give a particular diagram. We have to give that how we would be transporting our battery. So for shock and for vibrations, so special care has to be taken when these batteries are transported. So all these are the limitations pertaining to a lithium ion batteries. Need of a BMS. The lithium ion batteries can be used only in specified condition, and therefore battery management system is necessary in order to monitor battery state and ensure safety of operation. It keeps track to make sure that each and every cell must be kept within this minimal voltage. No cell must be allowed to overcharge or undercharge. So as we discussed like earlier, a battery pack is a composition, or it is a combination of cells. Cells are then like combined to form module, and then modules are connected to form a battery pack. Okay, so if you typically talk about even a small battery, if you talk about say 2 or 3 kilowatt hour of battery, if you talk about with a nominal voltage of say 72 volt, if you talk about, then that would be containing around 300-400 number of cells, cylindrical cells, if we talk about. Okay, so these 400 cells will be maybe we are bringing all the cells from a similar manufacturer, made in a single lot. Everything we are we would be we would be fully sure when we are assembling the battery pack. But conditionally based, every cell would be uh, performing in different way. Okay, so there might be conditions when one cell is discharging fast, another is not discharging that fast, one is charging fast, one is not discharging, one is holding some charge, other when it is discharging. So all these condition, so cells would be conditional based, every cell would be performing as a like a different candidate, it would be performing. So in order that these all cells combinedly perform and that performance is uniform. Okay, so when it is discharging, they are discharging at a single rate, and when charging, they are charging at a as a single unit. Okay, so instead of like operating in silos, they would be operating as a team or at a single unit, because we call it a, why we call it a battery pack. So this is found because of the combination of the cells, number of cells, but at the end of the day, it should perform like as a unit, it should perform as a pack. So who would assure that these cells perform equally, uniformly they perform, uniformly they charge, uniformly they discharge? Okay, so there has to be some master who would be monitoring all these conditions. So master of all these cells would be the BMS, battery management system. So what it would be taking care of, it would be taking care of that each cell, instead of performing on its own differently, uniquely, every cell, whether it's the numbers are thousands or 10,000s or more than that, they should be performing in such a way that they perform like uniformly they perform, and the output from the battery pack is like equal from each and every cell. So it's not that that performance of one cell is good and one is not good, because that is not good for our battery pack. If it is distributed equally, equally charging, equally discharging is happening in case of each and every cell, then we would be calling it as an idle battery pack. Okay, so that that assurance is given by the battery management system. So as we discussed earlier, the controller we discussed, the brain of the vehicle. So BMS is the brain of the battery. Okay, so BMS is the brain of the battery. It would be taking care of each and every cell performance, so that they perform equally, uniquely, they perform, and at the end of the day, the performance from the the battery pack is uniform. So that is assured by the BMS. So better the BMS, so better would be the battery pack. So battery management system, as we discussed. So like how would you identify a battery management system? As discussed, it is the brain of the battery. So in different kind of battery packs, the number of the cells may differ. They could be there could be different number of cells. So the battery management system would be assuring that that these cells perform uniformly, and the best output is assured from the battery. Every cell is at same voltage when fully discharged, and at the same voltage when fully charged. So in both the conditions, every cell should be like should hold equal amount of voltage, and equal amount of current should be withdrawn from each and every cell. So this would be assured by battery management system. So typically, as we discussed, that a battery pack, so normally the smallest unit are the cells. We combine them into parallel to form modules, and then these modules are then connected into the series, and from each and every module we will have like control cable, controlling connection we would be having, that would be connected to the BMS, and through this the BMS would be monitoring each and every cell in the module. So normally, typically, if you talk about the BMS, they would be available in certain amperage rating, and at the same time, they also call it as the S rating or serial rating. So S rating signifies that how many modules in series we can connect. So if it is a 10S BMS, then we can connect, at the most we can connect 10 number of modules we can connect. A module can have like n number of cells that module could have, but at the most we can connect 10 modules in series can be connected through this BMS. So BMS will not only be like managing the cells, it would be also taking care of all different functions also. So as the controller does, it also take care of the the thermal management in the battery takes care of, and at the same time it also takes care of it also sounds a warning alarm if there are different type of abnormalities happening in the battery, and at the same time some kind of it would be also taking care of some kind of imbalancing. Okay, if there are imbalance, so imbalancing is a condition in which the cells are not either charging at a particular at the same rate or not discharging at the same rate. So what happens is, typically say if there is one or two cells, or in one module, when discharging there is that is discharging at a faster rate. Okay, so what would BMS say if lower voltage that we have discussed, that if say if it is a NMC cell with the nominal 3.6 volts, so the lower voltage would be around 2.8 voltage would be the lower end voltage. Okay, so say if it is discharging fast, so one module would be discharging fast, then if it reaches 2.8 voltage earlier, then what happens is the BMS would be considering it as the battery has discharged, fully discharged, it would be considering it. So in that case, the charge left in other modules will not be utilized, and the battery would be giving a lower range than normally it has to give. Okay, so in the due to these conditions, the battery has to be, every time it has to be balanced. Balanced in a sense that charging and discharging in every cells happens at a same rate. So it is the also the the BMS is also designed in such a way that it also takes care of the imbalancing. So it would say if some cells are holding current, holding voltage more than other cells, so that what the BMS would do is BMS would drain this voltage from this particular cell, so that they also come to the same level of voltage. So this also is one of the feature of the BMS that it takes care of. At the same time, it also can be we can have a communication tool attached to it, so we can monitor the battery, how it is performing. We will not only collect data of the battery performance data also, but at the same time we can monitor the movement of the battery can be monitored. So last, when we were discussing on the charges and the charging infrastructure, there we discuss about the swapping stations also. So it is very important feature that we know where our battery is, in which vehicle it is performing, in what area it is performing. So so that can be done with the help of a telematic device that we could connect it with the that we can connect along with the BMS. So BMS will always assure that the battery is not charged more than the end voltage, it is not discharged lesser than the end voltage, and at the same time it would be also helping in balancing of the battery. It would be helping in the balancing of the battery. Thermal management it will be taking care of, and at the same time also it would be acting as a it would be utilized for communication and the movement of the battery. We could tracking of the battery. So BMS and overview. A BMS is defined as an electronic system that manages a rechargeable battery, single cell or battery pack by monitoring its state, calculating secondary data, reporting that data, protecting the battery, controlling its environment, and or balancing it. So as we have discussed it, so normally typically if you talk about a BMS, what a good BMS would be doing, it would be taking always monitoring all the features of the cells and the battery. It would be taking care of. So again, it has a programmable microprocessor into it, where we would be given certain set of data we would be putting in. So if a battery is charging, it would we will have a higher cutoff voltage and a lower cutoff voltage, under which it will not allow the battery to charge or discharge. At the same time, there would be if there are certain faults, say earth fault is there or short circuit fault is there, then BMS will be taking care of. At the same time, if there are reverse polarity, say if you have connected the charger in opposite polarity, that normally doesn't happen because the plugs are standard. But at times what happens is like there might be in issues that the wire of the charger is cut, and we have connected it like after cutting it we have connected it and we have connected in reverse polarity. So if that happens, then also like BMS will take care of it, will not allow the reverse polarity to be plugged in, the battery to be plugged in for charging. And at the same time, it will be taking care of the temperature that is building in thermal management it would be doing. And at the same time, it will be also emitting the data, like we can have features where we can control the movement of the battery, and also other features also can be taken care of. Its benefits include increased battery lifetime, improved reliability, maintaining the health of cells to deliver the required power, and subsequently reduction in operating cost of the battery system. So in any case, like if when we are dealing with so number of cells, if we talk about lithium ion batteries, so at any point of time we have to have a BMS. So with the use of the BMS, we are kind of several things are automated. Okay, so say when I'm putting my battery to charging, I don't have to maintain that after 2 or 3 hours I have to remove the charger, because the BMS has been programmed that above when it reaches to a particular voltage, it won't be, after that it won't be taking in charge. Okay, so this way the safety features is maintained, and at the same time coordinating with these number of cells, taking care of these number of cells, managing these number of cells so that the battery functions as a unit. So that is also not possible if BMS is not available, because here we are dealing with thousands of cells we are dealing. If we talk about a normal battery of 7.5 to 8 kilowatt, if we talk about, there will be 1,000 cells into it. Okay, so this way like BMS is the brain of the battery. As we have discussed, the controller is the brain of the vehicle. Same is BMS is the brain of the battery. So they would be doing separately, they would be doing their duty. So in case BMS feels that no, the conditions are not safe for the battery to operate, it would disconnect. Even if any safety features of the controller is bypassed, or if we have both are programmed at different levels, if both are programmed, say it could be so that we have set the higher and the lower voltage of accepting the charge we have set on higher side in case of controller, but if it is on a lower side in case of BMS. So if even their safety features are bypassed, or if they are not met, BMS will be like doing its duty, or like separately it would be doing its duty. Its main function would be taking care of the battery. So in any condition, whatever the condition has been specified, it would be taking care of. So these there is a typical, we have tried to show it through a typical a diagram. We have tried to show it, a block diagram we have tried to show. So battery pack, if you talk about, it's combination of number of cells. So number of cells are there, and this thermal 1, thermal 2, that these and current, voltage, all these would be connected, would be every time would be being measured by BMS. It would be like comparing it with the input data. It would be comparing it to the data that we have fed in during the programming of the microcontroller in the BMS. So it would be every time it would be comparing it, and it would be evaluating it, and accordingly it would be it would be instructing, or it would be allowing the battery to function. So any time it sees any abnormality, that at that same instant it would be either sounding an alarm, or it would be disconnecting the battery with the system. And cell balancing, as we discussed, that if there are some cells, if there are which are holding more voltage than other cells, and then that voltage would be automatically drained out by the BMS, so that all cells are at the same voltage. So an ideal battery is one in which every cell discharges at the same rate and charges at the same rate. Then the utilization of the battery and the performance of the battery would be the best. If there are cells, so typically what happens is like when you are using an electrical vehicle, after some time you see that the mileage of your vehicle has started dropping down significantly. So something which was giving you an average a run of 100 kilometers, now it is giving you an average run of 60 kilometers only. So this should not happen, because now the utilization has been only for 100 cycles or 200 cycles of battery life. So that condition occurs when the disbalancing of the battery takes care of. Disbalancing in a sense that some cells are either discharging fast or are charging fast. In that case, the BMS is the data that is coming to the BMS. It is when it thinks that this module has reached to its lower end voltage, then it would consider that okay, battery has been discharged, so it would be disconnecting, be allowing the battery to discharge further. So in that case, the mileage of the vehicle will be dropping down. So due to all these abnormalities, in case of an unbalancing of the battery, then we have to take it to the service center. We have to take it so that it gets again it gets balanced. So in balancing, they would be, what they will be doing, they would be assuring that every cell or and every module, they are first of all, they are at the same voltage, so that during charging and during discharging, equal amount of current is flowing through them, or when charging, they are accepting equal amount of current. So there is also a CAN bus controller. So through CAN bus controller, what you can do is you can receive data. Okay, so that could be either done with the help of through a cable, you can download the data, or there could be a provision where it could be, you could have a device installed where it could be giving you remotely, you could accept data through if it is connected to the internet, you could receive data at your end, and you can continuously, you can keep on analyzing, because at the end of the day, performance of the vehicle is also directly depending upon the performance of the battery. So 70% of the performance of the vehicle is dependent upon the performance of the battery only. So the data of the battery is equally important, or more important than any other data. So some of the key benefits of BMS, voltage. So it would continuously, it would keep on monitoring the voltage of the battery. So if the voltage, the higher side voltage has reached during charging, then it would disconnect the battery. It will not accept charging further. At the same time, the low end voltage, if it has it has discharged to the low end voltage, it will not allow further discharging, and it will disconnect the battery from the vehicle. Current, as we said, that every battery or every cell has a C rating. So if continuous current is flowing above the C rating, it would disconnect the battery. It won't allow the battery to further discharge at that rate, because that it would be sensing this as an abnormality or an extreme condition, and it would be disconnecting the battery for the safety of the battery. Okay. Temperature, even if the temperature rises from a certain extent, the operating range we have discussed, if in normal condition the temperature within the battery goes beyond that range, then also it would be sensing this as an abnormality, and it would be disconnecting the battery, or it would be sounding an alarm to the user, so that he can take care, or necessary he can take care. Okay. And state of charge or depth of discharge. So state of charge at any point of time, how much charge the battery is holding. Okay, so that would be state of charge, SOC, that we call. So it would be always, every time it would be showing to the rider, like at every instant, like what would be the state of charge of the battery, because during the move, we know that the voltage would be like changing, it would be reducing when we with every kilometer we gain, it would be reducing. So it would be always keep on showing you the actual or the instant, at any instant, what would be the charge that, or the voltage that the battery is holding, it will be showing it to you. And state of health. So state of health, if you talk about the state of health, is the number of the cycles uh, 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 which has been utilized for any battery. So state of health is, as we said, that every cell is rated for some number of cycles, so that it would be operating for these many number of cycles. So after, say, these many number of cycles, its life of, say, 80%, if of only it would be holding capacity would reduce to 80% only. So at that time, we would have it would be an alarm to us that now it is the time to change our battery. Okay, so state of health also will be monitored by the BMS. So at any point of time, through certain condition, through certain data, definitely displaying you at any instant as it shows that state of charge associate, it shows us. So it won't be showing us the state of health at any instant, but through some set of data that we would be accumulating from the BMS, we could assess, and we could have a like proper identification of like proper we can reach to particular levels where we can, yes, we can say that yes, it has been utilized for these number of cycles, and we can assess the life of the battery through BMS. So these data will also be coming to us through BMS only. Balancing. So as we discussed, balanced battery, if you talk about normally, how will we define a balancing battery? If a battery is charging, every cell is like discharging and charging at the same rate. So at the end of the time, say if a battery is fully charged, has reached to its like maximum upper limit voltage, if it is reached, if we talk, say we take an example of 48-volt nominal voltage battery, if we talk about a battery pack, we talk about, and if you fully charge it, it would reach to say it will reach to 54 something 54.6 volt, say we have set the limit, upper limit we have set. So every cell should be contributing such that every around cell, if we check, so every cell is fully charged and every cell is showing equal voltage. Okay, against it, if we see, every cell is at equal voltage. Individually, if we check the cell, say if it is comprised of 500 or 600 number of cells, so every cell is at equal amount of voltage. So that we will call it as a balanced battery. Same is case with the discharging also. Say this battery, we have utilized it, we have gone 60 kilometers, now it is fully discharged, the vehicle has stopped in now it is not allowing the vehicle to move further, so we will call it a fully discharged. So now if we check the voltage across every cell of the battery, if it is showing equal voltage across every cell, we will call it as a like balanced battery, we will call it, because it is discharging and charging at the same rate and every cell is contributing in that means. Okay, every cell is uniformly discharging, uniformly charging. So that battery, we will call it a balanced battery. So what happens is with utilization and conditional specific, at times what happens is like this scenario or this equilibrium in the battery is like disturbed. With time it is disturbed. So it starts with a very small amount which is mostly taken care of by the BMS, but when this difference or the bandwidth of say error between two modules or two batteries, when it increases from a certain level, it is not possible by the normal BMS to take care of. So that stage we will call it as an we will call it as the battery has lost its balancing, or it is disbalanced, in disbalanced condition. So what effect that would be bringing in on the battery is it would be giving us lower range and lower range. So it with what we were expecting, that it would normal vehicle which was giving us 80 to 90 kilometers of range, now it has started giving us like 50-60 constant 50-60 kilometers range it has reduced to. So at times it could be because of the condition of the roads, elevation, we could get some lower range, but when we start feeling that the considerably the range is depleted in say use of 100 cycles or 200 cycles only, and so that condition is normally we would call it the battery has gone into a disbalanced stage. So in that case, we have to take it to the servicing station. So what they would be typically doing, they would be again putting in effort so that every cell, they would equalizing the voltage of every cell through charger dischargers. They would be equalizing the voltage of every cell so that every cell comes to a particular voltage, and then they would be fully charging the battery. They would be doing this 3-4 times, 5 times, 6 times. They would be doing it to assure that yes, they are charging and discharging, every cell is charging and discharging at the same rate. So after first of all, in first step they would be they would be putting the battery so that every cell reaches to a particular voltage, a constant voltage it reaches, then they would be charging it. And then they would be analyzing that whether if only few cells are holding the full charge, or all the cells are holding full charge, or then after assuring that yes, every cell is on full charge condition, every cell is holding a particular voltage, constant voltage, then they would be discharging it. Another cycle they would be discharging. So they would be doing 5-6 times, they would be doing it, assuring it that yes, now it is in the balance stage, and then they would be again handing over the battery to us. So fit to again to use. And again we could claim our we could claim what mileage we were getting earlier, we could claim the same mileage also. So this is disbalancing of a battery. So cell balancing is the process of equalizing the voltage and state of charge among the cells when they are at full charge. No two cells are identical. So as we said, that definitely cells could be from the similar manufacturer, they could have same internal resistances and everything, but conditional base they might perform differently. Okay, so with time a portion, a small error would be corrected by the BMS itself. Okay, but if the error percentage increases, then the battery could go into disbalancing stage, and that can be taken care of only by the servicing station. So we have to go to the servicing station. So they would be equalizing the voltage. There are always slight differences in the state of charge, cell discharge rate, capacity, impedance, and temperature characteristics. So as we have discussed, so depending upon the conditions, the internal conditions, the cells might perform differently at different conditions, so which could result into disbalancing of the cells or the batteries. Okay, so that condition, if the error percentage, as we discussed, if it increases from a certain level, definitely we will start calling it as a disbalanced battery, and then the range will also fall down drastically. Cell imbalance is the main significant factor in large battery packs, which degrade the performance of the battery to be qualified by the state of health of the battery. Okay, so if this condition we prevails, so this error percentage that we are talking about, this gap keeps on increasing, and with utilizing factor, with more number of cycles being utilized, this error will grow, and we will only the cell life also will not be affected, but we will also be not getting the desired range or the rated range that the vehicle is meant for. So when we see these conditions, we see that there is a drastic fall in the capacity of the vehicle. We should like take it to the servicing station for balancing it at the earlier, so that the characteristics of the cell doesn't change drastically. Because when we are like utilizing cell at different conditions, so imbalancing in like disbalanced battery, some cells would be over pressurized, some cell would be lesser pressurized. So the over pressurized cell would be like degrading at a faster rate. Okay, so the entire health of the battery, SOH that we call, the state of the health of the battery, will also be disturbed. So when this condition arises, or if the battery is meant for some particular, say if they have like particular health check, if they have mentioned that after certain kilometers or after certain time we should be going for a health check of the battery, we should definitely do it. Okay, so this way what we would be avoiding normally we would be avoiding the further disbalance. Even if it is on even if it is on a starting base, we could we could correct it at that moment only. Otherwise it would be in a longer run, it would be not only affecting the mileage of the vehicle, but also the health of the state of the health of the battery also. So here we are like seeing conditions, say SOC percentage. So first case, if we see that it's showing imbalancing of the cells, it is showing. So 3 cells, they are at different voltage at certain point of time. So it should not be there. At any instant, they should be at equal voltage if it is a balanced battery. So this imbalancing can be either corrected through active balancing or passive balancing. So what is active balancing? Active balancing normally happens during charging. It can happen during charging and discharging both. And what in active balancing, what is done is all the cells which are holding extra voltage or extra charge, they are holding, that charge is distributed among other cells to bring a uniformity in the voltage. Okay, so during charging and discharging, the same amount of charge can be utilized to be distributed among other cells which are at say at a lower charge or lower voltage level. It would be given to them, and a uniformity would be achieved when all the cells have reached to a particular voltage. So this happens. Active cell balancing is it's a bit of complex balancing, because you can imagine that distribution would again need a lot of iteration, a lot of programming. It would need first of assessing like which are at higher voltage and which are at lower voltage. So accordingly, all those calculations would be done, and so it is a bit of complex technique. So during the charge and discharge cycle, there both during the charge and discharge cycle, this process can like take place, and thereby increasing system runtime by increasing the total usable charge in the battery stack, decreasing charge time compared with passive balancing, and decreasing heat. Okay, so what happens is since we are distributing the available charge, the available higher charge with the with some of the cells we are distributing among, so we are not losing any charge. Precisely speaking, we are not losing any charge. So this way what we are doing is what we are doing is we are not dissipating any charge. So better utilization of the battery. So instead of like draining out the charge, we are utilizing the charge for balancing of the battery. So it gives an it gives more usable. We can use the charge battery, we can use it, and maybe it would be like better during when we are charging it, since we are utilizing the extra charge. So the charging would be more efficient. It would be taking a bit of lesser time. It would be taking. In case of like now, what happens in passive balancing? Passive balancing normally occurs during the charging cycle. It normally takes care of. And during that, what we do is extra charge that any cell is holding, we drain it out. So that all the cells reaches to a particular voltage. So in this case, what we are doing is we are like dissipating the extra charge. So we are losing some amount of energy. Okay. So definitely this is an easier technique to do, because we can the programming is such that we have to only identify the cells which are at higher voltage, rest which are at uniform voltage. We define that yes, that those cells have to reach to that voltage. So just drain it out, the extra charge should be drained out. So that is typically much easier process of like balancing. But what we ends up is like we ends up losing some amount of charge, so that when charging, it would take a bit of more time it will take during the charging. Okay, so and during charging cycle, so that all cells charge to their maximum SOC. So both these are active and passive balancing are the methodology adopted for balancing of the battery. And like to be very precise, these are the methodology only for a very small percentage of error, and this would be taken care of by the BMS. So this would be in will be happening and taken care of by the BMS only. If the error percentage increases and if the unbalancing increases to a wider range, then we have to take it to the service station, as we told about. So there they would be using some sophisticated technique. So and again testing it battery for 7-8 cycles, they would be testing it to attain and again to achieve the equilibrium of the battery, and then they will be handing it over to us. So battery packing, if we talk about, so we discussed that the smallest unit are the cells. We assemble the cells, we connect them into parallel, and we form the modules, and those modules are then connected into the series. So along with BMS, we achieve the battery pack. So cells, then modules, and then battery pack. So cell to cell connection. Normally in these conditions, we normally use the nickel strips we use. Okay. If the battery, if the say if we are mid-range of battery, if we are using say 7 to 8 kilowatt of battery we are using, then we are using the nickel strips, because first of all like high tensile tension they have, low resistivity they have, low price they have, and improved conductivity they have. So these all features make nickel string a better way of connecting the cells. So interconnections when we are doing, as we know that we normally use spot welding process when we are connecting the cells through the nickel strip. So nickel strips better join when we are using when you are using the spot welding in place of another material. If we have utilized for connecting, then it is corrosion free. Then resistivity, as we said, that low resistivity, so losses would be very low. The temperature developed across the connections would be lesser, and low resistivity means improved better conductivity, it means. Okay, so resistance free it is. So even when some like due to temperature, when some fumes are generated or other gases are generated, then also it is it doesn't corrode very fast. So that is a big plus that we have like with nickel strips. And uh, it gets like with the spot welding, it gets very well we can joint the cells with each other through this nickel strip, so they connect very well through the positive and the negative ends of the cells. So bus bars, so reduce cost, improve reliability, increase capacitance, and improve thermal characteristics. So mostly we use bus bars when the we are utilizing cells of higher capacity we are utilizing, and when we have to when the battery pack is a bigger. Okay, so depending upon the size, either we would be using a nickel strip or the bus bar. So when the output current flowing through the connections is higher, and we think that nickel strips will not be able to take the capacity, then we would be using these copper bus bars we would be using, because they are thicker, and they can like more current can pass through them. Electrical connections, to get the desired voltage and capacity of the battery bank, we can make connections depending on the requirement. Series connections, batteries hooked in series will increase the voltage, but the amperes stay the same. Parallel connection, batteries hooked in parallel will increase the capacity. So as we said that the cells that are available to us are available in a particular voltage, in particular voltage only, nominal voltage are available to us. So when we have to make a desired battery pack of say a particular particular voltage and particular capacity, if we have to design it, so we have to connect the cells in series and parallel. So as every one of you know, when we are connecting the cells in parallel, so the voltage remains the same. So if I am utilizing, say I have been asked to make a battery of certain kilowatt battery, if I have been asked with through NMC cells with nominal voltage of 3.6 volt, if I have been asked to make a battery, so what I would be doing, first of all, let's say if it is a 48 volt battery, I have been said that you assemble a 48 volt battery, and 3.6 volt nominal voltage, and say 2.6 Ah of capacity every cell holds, we know that. So when we are to assemble the battery, first of all, what we do is we connect the cells in parallel, we connect to form the modules we make, separate modules we make. So like we know like in 2.6 H is the capacity of the every cell, and we have to achieve certain capacity. Say if we want to achieve 500 Ah of battery, if you want to make, then we would be connecting around 20 cells, we will be connecting in parallel, we will be connecting to achieve that Ah. So for capacity achievement, we will be connecting the cells in parallel, and to achieve the desired voltage, connecting those modules, we will be connecting in series. So voltage would be increased, or voltage would be achieved by connecting them into series, and the desired Ah would be achieved when we connect the cells into parallel. Okay, so this way, like a desired battery we can form. So limitations, you know that since the smallest unit, the cell is available only in particular Ah and particular nominal voltage at a nominal voltage level only. So like the battery also, you would be finding normally into that multiplication factor only. So say 24 volt or 36 volt, 48 volt, 60 volt, 72 volt, that in that nominal voltage only we will be finding the vehicle and the battery, because of the availability of the cell. So they are standardly available in a particular nominal voltage and a particular Ah level. So we would be mostly dependent upon them. So when we have assembled the battery pack, through each and every module would be connected to the BMS. It would be connected through a control cable. It would be connected so that BMS has certain ports. They have input ports they have, through which they would be, every module would be connected. As we said that every BMS would be rated for a certain current, and for certain S level or the series or serial ports that it would be having. So that many modules we can connect it in the series with the help of this BMS. So enclosure of battery pack, cell holders to hold the number of cells in the right manner. So there are like when we are assembling in the battery, we have to ascertain. This might be like many times we might neglect this thing, but the cell holders that we are using to hold it, so that we can hold the cells, because these cell holders would be utilized so that the cell don't move from their positions, and a particular air gap is maintained between the cells, so that air could flow through them to maintain the temperature of the battery. So when we are assembling the battery, especially take care of the quality of these cell holders, because at times what happens is like we neglect with these qualities, and uh, what could happen is they might not be like fit for withstanding certain voltages. So if any particular cell is heating up, the cell holder also might heat up and might affect the other cell which was in a healthy condition. So this way, like we should be when we are selecting these cell holders, we should be selecting them of very good quality. Okay, that quality management and quality control we should be asserting when we are purchasing these cell holders. So these cells will be placed in the cell holders, then they will be connected in series and parallel to make modules, and those modules will be connected in the series to form the battery pack, and we would be using the battery BMS we would be using. Now this has been done. We have been able to achieve on the battery pack of certain voltage level and certain age, certain capacity. Now we have to put this battery. We can't leave this as it is. Okay, we can't keep the cells exposed. So a particular this battery would be placed into an enclosure that we discussed about. So it should be an IP67 enclosure, waterproof and dust proof it should be, so that the cells are not exposed. Okay, to thermal shocks they are not exposed. They are not exposed even to the outer temperature and outer moisture and the dust also they are not exposed. So we have to put them into a particular enclosures we have to put in. So cell holders to hold the number of cells in the right manner, and BMS is attached with it for monitoring and controlling as we discussed. So the outer port that we are discussing, these two black and red wire that you could see, the both charging and discharging can be done through these same wire, but that would be done one at a time, either charging or either discharging. So some batteries they might have two connections. They might draw parallel connection from here also, so that they could have separate charging and separate discharging port, so that you don't have to every time you don't have to remove the discharging socket when you want to charge your battery. But there are batteries, in order to make them a bit cost efficient, what they do is they have a single socket for charging and for discharging both. So maintenance of batteries. So normally the lithium ion batteries that we are talking about, normally they are maintenance free, but as we discussed that during in the condition of disbalancing, we have to take it to the service centers for again balancing them. So batteries should be kept clean and free of dirt and corrosion at all times. So we should not be exposing them to like moisture at any point of time. So we should be taking care of this, that they are properly when they are placed in a vehicle, that is properly insulated, properly covered, so that normally not exposed to dust and moisture. Completely charge the battery before storing. So this has to be taken care of, like charging and discharging should be happening. Say not don't discharge to 100%, but at least 90% it should be charging. When you are charging, it should not be an intermediate charging, but it should be fully charged. You should assure that it gets fully, you are fully charging it and fully discharging it during the use. Store the battery in as cool a place as possible. However, do not store in a location that will consistently be below 32 degrees Fahrenheit. Batteries will discharge when stored. the lower the temperature, the lower the self discharge. So due to the temperature differences, what happens is if you are placing them at a lower voltage, that self discharge rate might be a bit higher in comparison to a normal moderate range type of conditions that you are keeping them. When not in use, boost every 2 months. So normally the self discharge rate that we are talking about is very slow in case of lithium ion batteries when compared to lead acid battery. So even if you are keeping them for 6 months, they might not go below. So not might go below the normal voltage level, the lower voltage level. Okay, so the condition that we call deep discharge. Okay, so what happens is the lower cutoff voltage of a battery, if it goes below that voltage, then we will call that as a deep discharge mode. So it won't start immediate charging by putting the charger. We put the charger, it will not start charging. So what we have to do is we have to lift that voltage at least up to the lower end voltage, so that through normal charges can start charging. So if you keep your battery for a prolonged, very long time, if you unattended, if you keep your battery, so due to self discharging, the condition might be there, then it could go below the lower end voltage and it can go into deep discharge. So at that time, it won't be like ready to use. It won't be ready to use. At that time, you might face issues that it won't start charging from through your normal charger, and you have to do something to lift the lower voltage to a voltage level to the lower end voltage. You have to lift it, and then you can plug in the normal chargers so that the charging could start. So you have to take care that you avoid this condition, and you are utilizing it like between times you are utilizing it, you're analyzing it, or you are charging it, so that even after a certain period of time, if you use it, it is ready to use. When not in use, boost every 2 months, that as we spoke about. So failure modes, a battery can degrade or can fail catastrophically. Modes are short degradation of electrode material, freezing, and increase in resistance. So this happens. So the resistance normally increases with the life of the battery. And as we discussed, that we should be taking care of while when we are utilizing our vehicle, we are not exposing it to extreme conditions normally, so that the battery parameters are maintained. And from time to time, we are also analyzing the battery, normally fully charging it, fully discharging it. And if there are, we are seeing that there are abnormalities in the mileage of the battery, we are going to the service station so that it gets attended. Normal issues can be captured. Initial level only they can be captured. And and we should be taking care of the service the service timings, and the service prescribed kilometers we are taking our battery for the servicing in time. So those things should be taken care of to avoid any failure mode. So because we have discussed that in case of lithium ion batteries, the failures could be fatal. They could affect not only the vehicle but also the driver, and the pillion also they could affect. But those things should be avoided, and from time to time we should be taking care of the battery, and we should not be exposing it and over pressurizing it. Battery safety and disposal. Most battery systems, including those used in renewable energy systems, contain corrosive or dangerous chemicals, and the safety regulation for each type of battery should be carefully checked. So we should not be, first of all, when we are disposing it, we should not be disposing it as it is, like we have thrown it into the garbage or so. At times what happens is, even say if your battery, we have seen conditions where battery has caught fire. So if it has caught fire, we have extinguished the flames with the help of, say, fire extinguisher. The flame has there is no flame coming out or no smoke is coming out, but that battery now, if kept unattended or not properly disposed, that can again catch fire. Okay, because that is again into abnormal conditions. Any cell can again can initiate the fire, again can initiate the same condition. So when either it has fully burnt or it has entire material, nothing is left in. But if it is if it is half fired, or if it is like still if some material is left in it, we should take care that it is very, very properly disposed through certain agencies or who are expert into it. Okay, it should not be thrown here and there, because that those conditions could initiate in. And or even if we consider that a small lithium ion battery, say, which is being utilized in our battery pack or into mobile or into laptops, we feel that no, it has lost its life, it's of no use, I've changed earlier battery and now I'll be throwing it anywhere. So the same condition in this battery can also be can also arise unattended. So small spark could take care of, which could cause a lot of like destruction, as we know, because most of the fire cases that occurs are because of the short circuit, and the short circuit starts with a spark only, and then it can take like it can destroy the entire premises or the entire buildings, it could destroy. So it has to be taken, utmost care has to be taken when we are disposing these batteries. Additional safety concern related to the ability to produce large currents. Finally, for lead acid battery system, the evolution of hydrogen is a potential issue. Batteries should not be thrown away, as most batteries contain toxic and corrosive material. As we said that they contain corrosive material, they are very harmful if disposed anywhere. If they are disposed, because lying there, they could develop certain conditions which could cause fire. In the case of lead acid batteries, definitely they have a very uh, 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 process where they can be recycled in a very efficient way. So before mostly people don't dispose their lithium ion batteries, so they will either sell it to the different vendors who will be definitely paying them some price, and they will be taking it, they will be recycling it, reclaiming lead, and they will be utilizing this in forming the new battery. So definitely same thing would be happening uh, uh, when lithium ion batteries would be used, more frequently used. But till now there is no such system. But they should not be exposed as it is. Definitely you should be connecting with the OEMs or the person from where you have purchased the battery before disposing it, so that he can take care of under safe conditions, he can dispose it. So thank you everyone. So this were two sessions where we tried to where we tried that we can maximum description and in depth we can know about the batteries. We have discussed most of the things in first session, and also today we discussed a lot of characteristics of the battery. So anyone, if anyone has any query, he can either raise his hand or he can put in the chat box.
Good evening, sir.
Yeah, Uday, good evening.
Sir, if we have 3 batteries in a vehicle, so if suddenly one of them is discharged, like a few seconds ago, it will be like a 70% of equally charged batteries. But
Your
suddenly
voice is
one of
like
them,
if you can bit speak a bit louder, Uday. Your voice is not very clear.
now is it okay, sir?
Yeah, please.
So if there are 3 batteries,
Okay.
so initially now, at the starting stage of vehicle, they are in 70% of charge.
Okay.
After 5 minutes, due to some internal issue, one of the battery discharged suddenly up to 30%.
Right.
So what may be the situation, how the uniformity will be done by other 2 batteries, and what will be the condition at that time?
So normally, see, if we are the battery that is we are connecting with the vehicle, we are not doing it as like all 3 batteries connected in parallel. They are connected with the vehicle. What is normally done is the other batteries would be in standby. Okay, so when one battery has lost its entire capacity, then only we will be plugging in the next battery. Normally they don't do it, because what happens is then all the factors would be defined by the battery which is draining fast. Okay, so conditions or the characteristics of that battery would be defined. So the range would be going down, and it would be performing, and it would be the voltage range that it is taking, it would be taking as per the the battery at the lowest voltage.
Yeah. Oh, okay, sir.
So it would be all the characteristics of the lower voltage battery would be dominating in this case. So normally what they do is they don't connect 2-3 batteries in parallel, but they maintain a separate battery for say for no, conditions like for emergency and all. That would always a standby battery.
Sir, you have said about
Otherwise,
like
otherwise, like I'll try to explain you what happens is in the battery, a battery pack, if you talk about, okay. Hello.
yeah, yes, sir, tell me.
So battery pack, if you talk about in some or the other, every module is acting as a battery only. Every module, if you talk about, they are acting as a battery. They are connected in series from a particular battery pack. Okay. Second, another battery pack, if you are maintaining, if you are connecting those in parallel, and then only you with the vehicle, so that your capacity increases. At the end of the day, connecting 2 batteries, 3 batteries is like connecting, like increasing the capacity of the batteries. My range of the vehicle increases, right?
Yes, sir.
But again, then
Sir,
that is like maintaining again. That is not doable mostly because they would these 3 batteries will have different BMS. They will have, okay. So coordinating these batteries, connecting them parallel, and taking care of equal conditions would be a bit different. Okay, so what they do is they maintain different batteries for only for emergency purposes or standby only they will keep. Okay, instead of like 2 batteries connect like parallelly or at any point connecting 2 batteries with the vehicle will not be any time will not be advisable, or any vehicle OEM will not be doing it. If he has 2 batteries in the vehicle, he will be keeping that separately standby, so that when one battery is drained off, he will be connecting second battery. Because connecting again 2 batteries in parallel is like again maintaining 2 batteries. Okay, again coordination of those BMS of 2 batteries. So if any vehicle is claiming to have 2 batteries, and second battery is normally standby battery.
Okay, sir. Like I think previously you have explained about TVS iQube. So
Yeah.
that is an undetachable pack of 3 batteries.
Yeah.
So
Normally
will be
backup 3 batteries, as we are talking about, so they will be like switching in 1 2 3, or like at one instant one battery would be utilized, then at certain second instant second battery, and third instant third battery would be utilized. Okay, but connecting them normally connecting them in parallel and being utilized, so they will have a system of like switching batteries. Okay, but at one point of time all will not be being connected. So why he has used 3 batteries, let me explain you. In normally what happens is, normally when we are making a battery pack, particular volume it will have. Okay, so where we will be placing in standard conditions in a scooty type of vehicle, where we will be placing our battery normally below the seat we are placing. Okay, in case of iQube, what he has done to give a boot space below the seat, he has placed all the batteries on the footrest. Okay, so there he has space constraints here. So okay, can't keep a very big battery over there. Okay, so he has divided into fragments. 3 batteries he has divided into. Okay, so that he can place those 3 batteries in the in at the place where he is keeping the footrest. Okay, so there he has one battery would be connected at one point, then there would be switching of batteries. Okay, normally automatic switching would be there, but at any point these batteries won't be functioning in parallel.
okay. So only one battery will function at a time.
Yeah, so
Yeah.
it has discharge, or it has discharge, so maybe second battery would be coming into function. Normally that would be, they would be utilizing this. Otherwise what happens is this gets again very complicated. It gets, maybe OEM can do it, but what happens is syncing again becomes very complicated, because already BMS is taking care of the equilibrium of the battery, then second battery is again there, then these 2 BMS also has to coordinate, right? So both BMS should be having like they should be communicating in such a way that every cell of both batteries are charging and discharging at the same rate. These 2 batteries are also at the different balance stage. Okay, so this process becomes complicated. Definitely OEM could go for that process also, but this complexity increases when you are going for such designs. Okay, instead of So normally a consolidated bag will any time would be better than like having different bags.
So you are mean to say like for BMS, it is difficult to manage at a time 3 of the batteries. What is the state of charge, or what is the thermal, what is the temperature?
Yeah, that I'm trying to say that every battery will have its individual BMS. The battery will be having, okay, if there are 3 batteries, 3 BMS would be there. Okay, so they will be taking care of individually, they will be taking care of their batteries, but at the same time when output is going, there should be a coordination, there should be a syncing between these 3 BMS also, right? Because if these 3 batteries are not charging and discharging at the same rate, again we will be not be getting the output, desired output we will be not getting. So there would be again one more step of synchronization, one more step of coordination would be there between these 3 BMS also. So that increases the complexity of the process. That is only what I'm trying to tell you. Definitely you can do it by programming, you can do it those things, but why have a complex product instead when you can have it through a consolidated approach? If you can have it, why have a complex product? Okay, why TVS iQube, why they have gone for 3 batteries? I have explained you the reason, because they wanted to place the batteries in the footrest. So so there they have definitely they have size constraints. Okay, so that is why they have gone for these 3 batteries.
Yeah, okay sir, thank you
Hope
sir.
I have clarified your doubt.
Yes sir, yes sir.
Okay. So there are some questions in the chat box also. Shruti has asked, what is the difference between battery used in IC vehicle and EV vehicle? So Shruti, normally in IC vehicle, we use a lead acid battery, a small lead acid battery is used. That is normally used only for the auxiliary supply of the vehicle, for the, say, for the horns, for the lights, and for the indicators and all those only we are maintaining. And also for the self start, we are keeping a battery, and that is lead acid battery. And that battery gets charged with the help of the alternator that is placed in the IC engine only, that is placed. So it keeps on charging also when the vehicle is moving. So lead acid battery normally used in the IC vehicles, and we use lithium ion battery. Even lead acid is used in the electrical vehicles also, but in modern electrical vehicles, we are using mostly we are using the lithium ion batteries. And capacity wise, the IC engine vehicle battery is a very smaller battery, as I said, only for auxiliary consumption. And this battery are like much larger, because they would be their function is to run the motor, so they are much larger with higher capacity. Hope I have clarified, Shruti. Then second question is from Sai Kundan. What is the difference in IC vehicle and EV battery, and what is the cost difference, and also what is the battery life, and also how battery will get tested? So as I said that in IC engine, we are using normally lead acid batteries. We are using a smaller battery. We are using normally meant only for the auxiliary of the vehicles and for the self start of the vehicle. Okay, they are smaller batteries. The charging, as I said, that there is a alternator placed in the engine itself, which keeps on when the vehicle moves, it keeps on charging the battery. So the battery life, if you talk about, that is 1 year or 1.5 years, depending upon the use. And secondly, if you talk about the price difference, then a normal lithium ion battery might cost, that battery would cost you around 11,000-12,000. Then the lithium ion battery would be costing you around 35,000 to 40,000, depending upon the capacity. Because in any way, when the lithium ion battery, see, in IC engine, petrol, diesel or gasoline would be running the vehicle. Okay, in electrical vehicle, the electrical battery would be running the vehicle. So you can imagine how important the battery is in case of electrical vehicle, and how big it has to be, and how high capacity battery it has to be. So there can't be any like comparison between an IC vehicle battery and a normal electrical vehicle. They are entirely different for different purposes. In electrical vehicle, the primary function of the battery is to run the vehicle. In case of IC vehicle, its use is only limited to running the auxiliaries and the self start. Okay, so pricing will be there will be a hell lot of difference between the pricing, mostly dominated by the capacity of the battery. Sai Kundan, I feel I have clarified your doubt. Then Harish Kumar, battery management system comes inbuilt in battery or a separate device. So normally battery management system is part of the battery. Okay, so when battery is assembled, it is connected with the BMS, battery management system. It is tested that this battery management BMS is functioning or not, because at the end of the day the cells are only the power storage, only for power storage. But what they have to do, how they have to function, when they have to go for charging, when they have to go for discharging, when they have to accept charging, when they have not have to accept charging, discharging, all those decisions, everything would be taken care of by the BMS only. So it is again the brain of the battery. The battery is useless without lithium ion battery is useless without a BMS. So it would be coming, every battery would be coming with a lithium ion battery would be coming with a BMS only. Harish, I feel I have clarified your doubt.
Actually, no, sir. Actually, what happens is now newer electric vehicles, they are introducing like a portable battery. Portable, you can remove the battery and you can get charged, and again you can. So doubt is, so BMS is inside the battery again, or it controlled by a charger, or
no, it is not controlled. Actually, it is into that enclosure that we have spoken about. Okay, so when the cells are connected in series and parallel, and when we have connected all these cells accordingly, and when we have reached the required capacity and the required voltage, then the BMS is very much connected into the enclosure only. So you'll not be able to see in the battery. You will feel that you will not be able to identify in the battery. You will only see the shape of the battery and a connector coming out of it for charging and discharging. The BMS will be inside the battery enclosure only, properly fitted, properly placed, and it would be inside the battery only.
Okay, sir. Okay.
So when you are removing, when you are plugging in battery, or when you are removing in the battery, you are doing it along with the BMS. So BMS will also go with the battery, or BMS will come with the battery, because it forms the internal part of the battery only.
Okay, sir. Okay.
Okay. Anything else?
Hello. Hello.
Yes, Arvind.
Good evening, sir.
Good evening.
Sir, while I was doing some research on EV cars and EV batteries, I came across a myth that EV cars reduce carbon footprints, but lithium-ion batteries produce 74% more carbon dioxide than gasoline cars. What's your say to this, sir?
So to be very frank, when we are saying that we are developing 100% like sustainable vehicle with the use of lithium-ion batteries, it is not 100% true, because first of all, for charging we are using normal electricity which is coming from the grid, which is dominated by fossil fuels only. Okay, we are using normally coal. So in that case, we are using electricity which is being produced by the burning of the fossil fuels, by burning of the coal or the gases. So there we have carbon footprints, okay, in charging, during the charging. Now, when you are manufacturing a battery, that time the lithium mining is involved, cobalt mining is involved, all other minings are also involved. So they are also putting some footprints, carbon footprints, they are also imposing. Okay, so carbon footprints, when you normally how you calculate the carbon footprints, you take the entire life cycle of any product. Okay, so if you talk about lithium ion battery, first of all, lithium ion battery, these elements have to be these elements that are being used, we have to mine these elements from different countries. So in the mining, you would be using different type of machinery. They would be emitting carbon. That will also contribute to the life cycle of lithium ion. Okay, now lithium ion has come, we have mined lithium ion and lithium and other elements. Now we would be going into the factory for production of these for formation of this cell. So this factory will again causing some emissions that will again adding into the carbon footprints. Okay, now these cells, now they have been assembled into a battery that would be adding some carbon footprints. This battery has been moved from one place to another. Okay, the logistics that will be involved in transporting this battery from one place to another, that will again be including the carbon footprints. Okay, then this has reached to a particular level. Now the charging would be including some carbon footprint. Now what additional benefit it would be giving us in comparison? So again, recycling or disposing it will be again adding some carbon footprints. And now what additional from a normal conventional vehicles, what would be the my additional savings? So when I subtract that from this additions, then I will be getting my net carbon footprints, whether it is zero, it is negative, or it is positive, I will be getting the footprints. Okay, so this way the footprints are calculated. Okay, so what you are saying, yes, definitely it could be like more than IC engines also, because we are if we are not safely disposing it in charging, if we are using more fossil fuel based power we are using, then definitely it could have more carbon footprints than the IC vehicle. So I told you the entire way of calculating the carbon footprints. Okay, so this way they calculate the carbon footprint. So this could be positive, this could be negative, this could be net zero, this could be zero also. So this way the contribution could be, so during the life cycle, the process involved, so any point portion can involve more carbon emissions than reduction.
Sir, in every stage we are seeing that smaller or the less carbon emissions are there, then how far we can say that we are building eco-friendly vehicles to the whole?
So this way, how will you define yourself? See, every process will involve some carbon emissions. Every process, whatever, when you come with any product, it has to be processed, it has to be developed into a product, so that will involve carbon emissions at one point or another of its life cycle. So how can you emit carbon emissions? So you must have heard that the trees, they are the best for carbon sequestration, they are best for carbon sequestration. So equally,
Yes.
either you have to go for plantation. So what you are doing, whatever you have emitted, you are planting more trees and you are sequestering that carbon that you have released during the life of the product. So this way only you can achieve net zero. Otherwise, every process will involve some carbon emissions at one or the other point of time. Okay, so there are some, say if you are going for solar plant, the production of the solar cells will also involve carbon emission. So how will you sequestrate this carbon? The best way is afforestation, planting more and more trees, then only you can go to net zero or negative.
Sorry for disturbance.
Yeah.
Sir, can you give hosting to me, sir, or else please give co-host to Sujay, sir.
Okay, I'll unmute Sujay, sir.
Yeah, I'm sorry, I'm just jumping into the debate. It's a fairly complicated question. Guys, am I audible?
Yeah, you are audible, sir.
Now, this is a fairly complicated question of how we are reducing the carbon emission in lithium batteries or in lead acid batteries. To be very frank, there is a ballpark comparison of the tailpipe emission vis-a-vis petrol vehicles. Now, to be very frank, there is a clear-cut case study which is there for ballpark to ballpark comparison, which means per kilometer that you drive on a petrol vehicle vis-a-vis per kilometer that you drive on an electrical vehicle, what is the carbon reduction? That's a straightforward ballpark figure. The second thing which is highly controversial is the cost for production of lithium and electricity which is being paid is also being driven by coal, gas, or polluting fossil fuel based electricity, which the ICE lobby wants to be calculated as part of your carbon emission. But what happens, the carbon footprint for creation of lithium batteries is much less than carbon footprint for generation of crude oil. Because crude oil does not come without carbon emission to your doorsteps or your petrol pump. When it is pumped out, there is a lot of energy spent, which is again driven by petrol or diesel generators. When it is shipped across the seas via high seas, they use naphtha and highly polluting fuels for transporting on large ships and vessels. Finally, when it is refined, then again there is a huge carbon footprint which is created when you are refining petroleum products from crude oil, and ultimately from the refinery to your petrol pump, there is a diesel vehicle which is also bringing that fuel. So there has been no study as far as this activity, which is from the field to your petrol pumps or to your pumps, how much carbon dioxide is emitting to bring 1 liter of fuel. Hence, this entire comparison where They are claiming that there is carbon dioxide created while you are mining lithium and processing it. And then there is carbon dioxide generated while creation of electricity. To be very frank, the overall basket of India, if you see for renewables, coal contributes to just 54%. Remaining 46% is due to solar, wind, as well as hydroelectricity in India. So that's a fairly large footprint as far as Indian electricity production is concerned, where we are close to 50%, not exactly 50%, but close to 50% on renewables. Now, we obviously hydroelectricity has a very large footprint in this. Solar and wind are still not beyond say 11-12%, maximum 14%. But hydroelectricity definitely has a fairly large footprint in this. We are still dependent on thermal, and nuclear is very minuscule. Again, nuclear is very debatable because there is zero carbon emission as far as nuclear fuel generation generated electricity. But it's a dangerous fuel to handle. So this debate of carbon dioxide generation on lithium, it's a very subjective debate because we still don't have proper format of the research data. So I hope I have been able to answer that particular question.
Yes, sir. Okay. It means that comparatively, making of petrol from crude oils and making of lithium ion batteries from coal, processed.
Not only that, you see, lithium ion batteries need to be charged by electricity.
Yes.
Lead acid of batteries also need to be charged by electricity.
Yes.
So every kilowatt that you are charging comes 54% from coal waste electricity. Burning of coal creates carbon dioxide. So the logic which was given was that you've just pushed your electricity production towards the coal burning rather than doing it in city. But nonetheless, 44% of our electricity is still coming from renewables, which do not create carbon footprint. So we are still some 5-10 years away from that ideal scenario where coal becomes less than 20-25% and 75% is on renewables. Technically, if we go on a massive spree to develop our power through nuclear generator power plant, we will bring our coal emissions down.
Yes. Hello.
Yes, someone else raised a question, hand.
There is a question from Shiva Teja. Will you explain again passive battery cell? So Shiva, like passive, it is not passive battery cell, but it was active and passive balancing of a battery. So if about passive balancing, then what happens in passive balancing is, say if some cell is at a particular voltage, some 10% cells are at a particular higher voltage and 90% are at a lower voltage. So additional charge that these 10% cells are holding, it would be drained out. That would from them, so that all the cells, all 100% cells come to a particular voltage, and normally this would be done during the charging stage only. So this is what passive battery balancing is. Shiva Teja. Then Lakhan has asked, sir, which is the most suitable lithium battery for EVs? So if you talk the chemistry, initially the chemistry was NMC. Now they have started using LFP batteries. The LFP batteries like a bit expensive, but they are more stable and they have better more number of cycles they have. So modern vehicles are mostly coming with the LFP batteries only. So you could say that suitability wise or safety wise, if we talk about suitability wise, LFP batteries are better. The ranges decreases when compared to NMC battery, but they have better safety features. He has asked what is the extra features that you like to add in BMS. So additional features, definitely communications we could add in the BMS. There would be some set of basic features that BMS has to have for the safety of the battery and the operations of the battery. In addition to that, definitely we would like the BMS to be a communication mode on also, so that it is emitting data which we could collect it either through either we can download it through a port, or it is emitting data which we can collect it remotely to see the functioning of the battery. the features of the battery, the performance of the battery at different condition. So that could be additional feature, which is normally a customized one. It doesn't come with most of the BMS. Any more queries, students? If anyone want to ask anything?
So it's already around 8:23.
Yeah,
I
yeah.
guess we had a great session. We were able to learn about battery chemistry, balancing BMSs, the current lithium-ion batteries being utilized, and the carbon footprint. The fact is, lithium-ion batteries actually help in reducing. Technically, we can't do zero carbon footprint. That's why this word net zero started. I don't know how many of you are aware of the concept of net zero. Those who are aware may write yes on the chat box. Those who are not aware may write no. I am waiting for the answers. There is a concept called net zero. Net zero means whatever activities of industrial production you are doing, it should not create carbon dioxide, or it should have a minimal impact on the creation of carbon dioxide in the environment. So right now, nobody has a very clear-cut clue as to how it can be done, because whatever you do, even the breathing that you are doing generates carbon dioxide. So you won't kill yourself exactly because we don't want to do carbon dioxide emission, right? And we can't change the chemistry of our body. So industrial production, whatever you do, you require energy. Energy has to be done by creating coal or some kind of fuel, petrol. Whether you want energy to drive your vehicles or you want energy to drive your factories, you end up burning some kind of fuel. In case of renewables, say like hydroelectricity, which is created by dams and water or gravitational pull, we don't create any carbon dioxide. Same is the case with wind power as well as solar power. Solar power has its limitation, as in you can generate energy only during the day. You can't technically use it at night unless and until you don't have the battery. So wherever there is a potential where carbon dioxide emission is zero, they are in such a situation, you are creating net zero effort. So have you understood the concept of net zero? That means any industrial activity where carbon dioxide production is zero is called net zero. Technically, no company or industry has been able to achieve, because it's going to take us some time to learn various alternative ways of how not to produce carbon dioxide. And this we are doing primarily to safeguard our planet from the heating that is being caused currently, which is primarily because of production of carbon dioxide. Anything you burn on this planet, like coal, fuel, petrol, firewood, anything, even your natural fires which are occurring or volcanoes which erupt, they create carbon dioxide, and carbon dioxide is directly proportionate to the temperature increase on Earth, which ultimately leads to extreme climate conditions like either droughts or flooding, because the entire climate cycle is getting disturbed very badly. So you are seeing the ice at the polar caps melt. Say, for example, there is flood in large parts of India and large parts of Pakistan, and there is drought in China. So this is an extreme of the environment which is happening. It's directly responsible because of our inability to control emission of carbon dioxide. So guys, have you been able to understand this concept of net zero emission now, or you would require a separate session? Everybody has mentioned no. So we will take the separate session on carbon net zero when we meet in Hyderabad, not now, because all your other sections are already cut out. And I guess we are already behind schedule by one presentation, as well as, the final assessment that we are talking about. Renuka, have we given the third assessment to the batch? Have they been given?
Yes, sir.
Great. So by next Wednesday, we expect that all the results should come through, because this coming Saturday is going to be the last session we do online, and Monday onwards, that is next week, Monday onwards, we will be starting full-fledged courses. So
Okay.
prior to that, we will share what all tasks all the groups or the 7 groups have to do. I believe all have undergone their presentations.
Yes, sir.
Yes, sir. All the 7 groups have given their presentation.
Great. So even in these 14 days, the first half of theory, today was our 13th presentation or 14th presentation?
14th, sir. 14th, sir.
14.
So we have already undergone 14. We have 3 more presentations. Now we have 17 presentations, and finally Saturday we will conclude the entire online classes. So these 14 days, that is starting from 12th onwards till 25th, including the Sunday, every batch will get a presentation on the subject that we has been taught. Right? You have to improvise these very questions, because we are going to monitor you on how you are presenting this particular subject matter. That is what will happen in the first day. Yes, Shivaram, your hands are raised. You can ask your question. Shivaram, have you already asked your question, or do you want to ask your question right now?
Nothing, sir. The net zero session, I want a separate session.
Okay. Net zero, we will take it up during the fag end. One more request that I am doing, because you guys are either freshers or experienced. 24th, which is a Saturday, one day prior to your last session day of the theory, we want to invite a couple of startups or existing EV companies. If any one of you knows about EV companies, you can recommend to Edify team, Rohit sir, or Renuka ma'am, right? 24th evening, 4 o'clock. It's a high tea for startups. The objective is to get you to introduce to what is happening into the market. There might be some special request which may come across for the electric vehicles that we are showing. So you will get exposure of at least 3 electrical vehicles. We'll try to get more of that. But any person who knows of any EV companies directly or indirectly, and those EV companies want to come and meet us to showcase their products or to have an interview with you guys, they are welcome. We would love to have them. It's an open networking invite. So we are also trying to get some of the EVs companies together. This is 24th. Please remember 24th. By this coming Saturday, I'm going to ask each and every one of you who has contributed to this effort. So it's an open networking session. There is no limitation. We are not charging them anything. Anybody and everybody who's interested is welcome to come there. We are going to display a couple of electrical vehicles on which you guys are going to showcase your skills. And parallel to it, whosoever is interested in kind of placements or such activities, we will initiate that. Mind you, this is initiation. This is not a instant gratification. We will start telling how we have trained you guys, and at the same time, we will ask industry what they would like to have in your individual approach. Right, guys? In the meantime, our session is going to be interactive. I am not coming there to train or teach. Whatever is being trained and taught is being given by Govind sir. That is going to be a completely American style, case study approach, because you guys would have undergone 17 sessions on the theory part of it. Now you have to present the theory, because we want to understand how much of it has been understood by the batch. And on that particular theory, there is going to be either a case discussion. Apart from this, we are going to get 4 or 5 different case studies, which we will try to entail has got maximum practical side. Some amount of financial planning will be there. Right now, our current case studies were purely product based. When we meet physically, there will be some amount of financial jugglery also that we will ask you guys to do or rack your brains. But that is what will happen at Hyderabad. Immediately, we want all these sessions to be internalized. If you have some knowledge, you do it. A majority of these sessions are already online. Are you aware that these lectures are online? Friends, are you aware that these lectures are online? You can write on the chat box yes or no. Renuka, are the batches aware that these sessions are online?
Yes, sir.
Okay, great. So in case you want to undergo or try to understand, normally we take 2 days to upload these recorded sessions. You can start brushing up, because when we meet in person, we are going to have a one-on-one with every individual candidate participating here. So you have to have your eyes, ears open. We will be asking you questions, as well as we are open to be asked these questions. A lot of things are still to be discovered in the electrical vehicle field, right? But session is interesting only when everybody starts asking questions, as well as we go positively towards a particular direction. So guys, thanks a ton for your participation. I saw better participation today, slightly better than what happened day before yesterday. But nonetheless, best of luck, and we will meet again Wednesday. Our next session is on Wednesday.
Yes, sir.
Yes,
Next session
yes.
is on Wednesday.
Next session on Wednesday, sir.
Great. So we take the next session, which is the 15th session on Wednesday. Thanks a ton.
Okay.
And in the meantime,
Thank you,
please,
sir. Thank you, Sudhir, sir, and thank you, Govind, sir. Thank you for everyone.
thank you very much.
Thank you.
you, sir.
Thank you, students. Thank you, Sujoy, sir. Thank you, Renuka. Thank you, everyone. We meet on Wednesday.
Yeah.